Welcome to EDU World Space.
Let's graph the curves y equals x to the n on the same screen, where x is only going from 0 to 1. So let's do n equals 0, so y equals x to the 0 equals 1. This is the first curve. It's just a horizontal line, y equals 1. Then you could try another number. Let's try n equals 1. So you have y equals x to the 1 equals x. That's just this line through the origin with slope 1, more or less. Let's go for another, x squared. This is our parabola, and we could plot some points here to see that the parabola actually lies underneath. So the common theme here is every time we draw a new graph, it's actually going to be below the previous graph. And the reason for that is that when you take a number between 0 and 1, the higher the power you multiply it, the more times you're multiplying a small number. That's going to make the overall number, the resulting number, much smaller. So I'll do one more here. Let me go back to red, y equals x cubed. Then here, if we were to plot this one, you'd get something that's even lower than the blue. And we'll just continue to have pictures that look like this. So that's the graphs on the common screen. That's the first part of the question. Now let's find the areas between successive curves. So what this means is this triangle right here, this would be the area between the first two curves. So that would be area 1. Here between the green and the blue, that would be the area between the second and third curves, and so on. So let's go ahead and find that. And by you doing this, we'll give a geometric illustration of this fact here, this infinite series that's equal to 1. So we'll try to explain why this equation is true by adding up all of these areas in the figure. So let's go ahead and, well, we know that if we add, so let's make an observation here. Let's just write it this way, since I've called A1 plus A2 plus A3 plus ... What should this, if I keep doing this forever, what's the sum going to go to? And I claim it'll be 1. And the reason is, if we continue to just add in these graphs, and if we just find all the areas, A1, A2, A3, and so on, we're eventually going to get the area of the entire square. And that's just 1 times 1. Base is 1, height is 1, so the area, the total area is just 1. On the other hand, I know that the area between two successive curves, top minus bottom, this is equal to AN. So really here I should do for AN, let me take a step back here. So this should be AN plus 1. So it looks like here I should start N to be 0. So if I add up all the A's, N equals 0 to infinity, AN plus 1. So this is the quantity that we want. So that's equal to the sum from 0 to infinity of x to the n minus x to the n plus 1. And then I have to integrate this, 0 to 1. All I'm doing here is just using the definition of A to replace A with the sigma notation. Now, let me bring this to the other side over here since I'm running out of room. This we can write as the sum from 0 to infinity. Now let's use our integration. So power rule there. Power rule again. Now plug in those endpoints 0, 1. So n equals 0 to infinity, and then plug in the 1 and the 0. And then just go ahead and simplify this fraction. You could go ahead and get a common denominator there. So I'm getting 1 over n plus 1, n plus 2. Or really, you could have also telescoped. I should have mentioned that. You could telescope here if you want to. You'll get the same answer. But here, the reason I wouldn't telescope is because we have a specific goal in mind, and we would like to see this sigma notation eventually arise in our work. That way we can justify the result. And so here, actually, we can do that at this step. So I have the sigma that I want right here. I claim this, we're basically finished. But to make it more obvious, if you notice, our denominator is different than theirs. But the reason that's okay is because they're starting at a different end than we are. So here, let's go ahead and use a different letter. Let's replace n with k. So if n equals 0, this means k equals 1. So I can rewrite this using a new sigma here. So let's use k equals 1 to infinity. And then I have 1 over n plus 1, that's just k. And then n plus 2, that's just k plus 1. And this is the same as the sum that was already given. And we know that this must equal 1 because this is equal to the sum of all the a's. And as we already pointed out, the sum of all the a's equals 1 because that's the area of the entire square. So this argument, that counting the areas between the successive curves, gives a geometric explanation for why this infinite sum is equal to 1. And that's our final answer.